Today, we're going to take a look at solving quadratics with the quadratic formula. The first thing I want to do is show you where the quadratic formula comes from. But if you're not interested in this, you can go ahead and skip to the next slide where we'll take a look at how to use the quadratic formula. The way they created the quadratic formula was to take the standard form of a quadratic, ax squared plus bx plus c, equal to 0, must be equal to 0 to use the quadratic formula. We take this equation and complete the square on it and solve for x. Think about what we did when we solved by completing the square. The first step was to move that constant, which is the c here, to the other side. We take a c off each side, and we get ax squared plus bx equals negative c. The next step was to make sure the coefficient of the squared term is 1. There's my squared term right there. I need to make sure that it's 1. To make the squared term 1, we'll divide every term that is, by a. The a's cancel. We get x squared plus b over ax equals negative c over a. Here's where it gets a little weird. We take the coefficient of x, that's b over a. We take half of it. To take half of a fraction, the easiest way is just to multiply by half. That becomes b over 2a. Once we take half of it, remember that we square it. Take b over 2a and square it. That's b squared over 4a squared. And we're going to add this to both sides. We now have x squared plus b over ax plus b squared over 4a squared equals negative c over a plus b squared over 4a squared. It may not look like it, but this is a perfect square. It always is when we take half the coefficient of x, square it, and add it to both sides. What would it be then? We know that it's going to be something squared. We know that x times x is going to make x squared. We know that b times b is going to make the b squared up top. We know that 2a times 2a is going to make the 4a squared below. And our sign is going to be a plus and a plus if we write this out. On the right side here, the problem is we need a common denominator. We need to make the 4a squared and the a the same denominator so that we can add these fractions. The way we do that is do the least we can do to multiply the a by and make it 4a squared. Well, notice that a times 4a is 4a squared, but when I multiply the bottom by 4a, I also have to multiply the top by 4a, because I'm really multiplying by 1 when I get a common denominator. What I get then is negative 4ac over 4a times a is 4a squared plus b squared over 4a squared. This becomes x plus b over 2a, quantity squared, equals, everything here is a common denominator, 4a squared. We keep that denominator, and I'm going to change the order. I'm going to put the positive b squared in front and the minus 4ac there at the end. We're at the point now where we can solve it. We take the square root of both sides and put a plus or minus over there. We have x plus b over 2a equals, and we're going to split up the root. We have a plus or minus, and up top we have b squared minus 4ac. And down below, we have the square root of 4a squared. We can do that. The square root of 4 is 2, and the square root of a squared is a. Now we're at the point where we can solve for x. We'll take a b over 2a off each side. This becomes x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Notice the common denominator. They both have a denominator of 2a. We can combine this into one fraction all over 2a, and we get negative b plus or minus the square root of b squared minus 4ac all over 2a. This is known as the quadratic formula. All you need to do is read off a, b, and c when the equation is equal to 0 in standard form, plug them in the formula, and work it out. I recommend jotting this down in your notes. Also, standard form. You must read off A, B, and C. In our next slide, we'll take a look at how to use the quadratic formula to solve a quadratic. Question 1. These are all broken into several steps as you complete each question. The first thing to remember is that your quadratic must be equal to 0. It must be in standard form so that you can read off A, B, and C. A is in front of the square, B is in front of the x, C is the last number. A is 1, that's 1x squared. B is 3. C is negative 1. We're going to use this formula right here to solve the quadratic. First thing we do is the opposite of b. Notice the opposites out here. All I'm going to do is put the b number here. If b was negative 3, I would put negative 3 there. The next thing is b squared. That's 3 squared. Minus 4 times a times c. A is 1 and c is negative 1. All over below is 2a. That's 2 times 1. First, this is the opposite of 3. That's negative 3. 3 squared is 9. And 4 times 1 times negative 1 is negative 4. 2 times 1 below is 2. We'll simplify this further. This is negative 3 plus or minus 9 minus negative 4. It's a double negative. That's 9 plus 4 is 13 all over 2. There are no perfect squares in 13. It's a prime number. One of our answers then is negative 3 plus the square root of 13 all over 2. And the other answer is negative 3 minus the square root of 13 all over 2. Question 2. Make sure your quadratic is in standard form equal to 0. Ax squared plus bx plus c is what we're looking at, equal to 0. A is in front of the x squared, b is in front of the x, c is that last number. A then is 2, b is negative 6, and c is just 1. First thing we have is, looking at the quadratic formula, the opposite of b. That's the opposite of negative 6. Plus or minus the square root of b squared, that's negative 6 squared, minus 4 times a, which is 2, times c, which is 1. Below we have 2a, that's 2 times 2. The opposite of negative 6 is 6. Negative 6 squared is negative 6 times negative 6, that's 36. 4 times 2 times 1, that's 8. All over 2 times 2, which is 4. This is 6 plus or minus 36 minus 8 is 28 all over 4. 28 has a perfect square in it. 28 is 4 times 7. We're going to write this then as x equal 6 plus or minus the square root of 4 goes out in front of the root as a 2, 2 root 7, all over 4. The thing you need to understand is that there are 3 terms right now. One of the terms is 6, one of the terms is 2 root 7, and the other term is 4. All 3 terms have a common factor in them. They're all divisible by 2. That's my next step. Divide them all by 2. 6 divided by 2 is 3, plus or minus. 2 root 7 divided by 2 is just root 7, because 2 divided by 2 is 1, and 1 root 7 is still root 7. 4 divided by 2 is 2. What we did then is we took every term and divided by 2 because there was a common factor of 2. This is 2 solutions. One is 3 plus the square root of 7 all over 2. And the other is 3 minus the square root of 7 all over 2. Question 3. Make sure quadratic is equal to 0 in standard form. Ax squared plus bx plus c is what we're looking for, equal to 0. A is in front of the x squared, b is in front of the x, c is the last number. A is 9, b is negative 2, and c is negative 6. First we have the opposite of b, the opposite of negative 2, plus or minus b squared under the root. We have another negative 2 here, that's negative 2 squared, minus 4 times a, 9, times c, negative 6, all over 2 times a, that's 2 times 9. Let's simplify this. The opposite of negative 2 is positive 2. Negative 2 squared is negative 2 times negative 2, which is positive 4. 4 times 9 times negative 6. 4 times 9 is 36. 36 times negative 6, I'm entering this in the calculator now, is negative 216, all over 2 times 9, which is 18. Notice the double negative right here. That's 4 plus 216, which is 220. 2 plus or minus the square root of 220 all over 18. Now I know 4 divides into 220. Let's try that. 220 divided by 4 is 55. That looks like what it is. I'm going to make 220 4 times 55. This will simplify then to x equals 2 plus or minus 220 is 4 times 55. The square root of 4 is 2. That goes in front of the root. Left underneath the root will still be the 55, all over 18. There are 3 terms in this expression. 2 is a term. There's the sign that separates them. Plus or minus is just a sign. There's my second term, and there's my third term. Every term has a common factor. They're all divisible by 2. So we're going to take and divide every term by 2. And this will become then 2 divided by 2 is 1, plus or minus 2 root 55 divided by 2. The 2's would cancel because 2 divided by 2 is 1. 1 root 55 is root 55. 18 divided by 2 is 9. I have 2 solutions then. One is 1 plus the square root of 55 over 9. The other is 1 minus the square root of 55 all over 9. In our last example, we're going to take a look at how sometimes you can even get nice answers, or at least whole number or integer, maybe fraction answers. Let's give this a try. Let's make sure our quadratic is in standard form equal to 0. Ax squared plus bx plus c equals 0. It is. A is in front of the square, b is in front of the x, c is our last number. I can see that a is 3, b is 2, and c is -1. First we'll plug in the opposite of b, so this is the opposite of 2, and then under the root, b squared, that's 2 squared, minus 4 times a times c, which is 3 times -1, over 2 times a, that's 2 times 3. Bring that down, that becomes -2. 2 squared is 2 times 2, 4. 4 times 3 times -1 is -12. All over 2 times 3 is 6. This becomes -2, and 4 minus -12 is a double negative. That's 4 plus 12 is 16 over 6. This simplifies to -2 plus or minus. The square root of 16, it's a perfect square. We can do that. Square root of 16 is 4. No more root. All over 6. This is two answers. One is -2 plus 4 over 6. These are all numbers that we can simplify. -2 plus 4 is 2. 2 over 6, and that reduces, because they're both divisible by 2, to 1/3. The other answer is -2 minus 4 over 6. -2 minus 4 is -6 divided by 6, and that's -1. Our two solutions are 1/3 and -1.